slide for you because I feel this is the best way these questions, these 5 questions are the best way to learn what to do, what not to do. So, I made a list of reactions. Wrong place. Here. This is what I told you. But now I made a list of reactions. As a student. If I'm a student, I'll do this for sure. Which compounds form primary alcohols? Which compound from secondary alcohols? Which compound from tertiary alcohol? Which compounds can form carbon-carbon bond to form alkane, alkenes? This is you learned in this chapter. That's it. That was this chapter. How to prepare primary alcohols, how to prepare secondary alcohols, how to prepare tertiary, how to make a carbon-carbon coupling, alkane, alkene, alkynes. Then I wrote the organometallics. I can get any one of them to do this reaction. These 3. But only these 2 can do this reaction. Coupling. And in addition to that, organoboranes. This is how I prepared my list. Then where to think? What to think at the time when the exam question is going to come? Can you walk us through? Of course. Here, look at carefully. You made carbon-carbon bond. Suzuki reaction. Did you see carbon-carbon bond? Right? Did we use lithium here? No. So this is carbon-carbon. Where else you made a carbon-carbon bond? Right over here. Look, I made a carbon-carbon. I always get confused otherwise. What the heck is where to look at? Unless and until I make a list on my own to process the things correctly, these slides go all over my place. I say, what the heck? What are these slides are trying to teach me? If I don't get that, it's a disaster for me because I don't know what they're talking about. So, do I need to know the mechanism of these reactions? No, I just want everybody to understand the meaning of this slide, only this slide. Only this slide I want you to understand. That's it. What is the meaning of oxidation addition? What is the meaning of reductive elimination? If I show you 3 reactions, can you tell me this is oxidation addition, this is elimination? That's it, recognizing. No mechanisms. And then what are yours? All those stupid slides are telling us. Just giving examples. That look what is happening. This is oxidation addition. Look what is happening. Reductive elimination. You see what I'm doing? So these all rest of the slides from slides 12 to slide 12 and 13 and then go to slide 15. So all 12, 13, 15 is just exemplifying those steps. That look, I'm showing you an example of addition. Look, I'm showing you example of reductive elimination. Nobody's going to ask you any question from there. So I'm not worried about that part. I'm worried about, do you know where the carbon-carbon coupling occurs? And I said, oh, Suzuki reaction or organocuprates. No, greenhouse agent never does that. And think about it, I'm giving a question like this. Which of the following organometallics will form this carbon-carbon double bond? And if a student said, I use organolithium. Wrong. Organolithium is a different compound from organocuprochlorite. It's a different story altogether. And every time I've seen the student mixing up the two, I said, oh, I told you in the beginning, make a list. Because you mess up this together. So now, we go back to a list. How do you prepare primary alcohols? We made a list in the lecture. So I said, okay, what if I use substrates? What substrates can I use here? So I made a list of substrates. I made a list of substrates. And I made a list of substrates. And then I wrote the answer that I know how does these substrates behave. That's chapter 15, done. That's chapter 15. It's the same, the higher order cuprates. Cyanocuprates, they are also cupric acid. They are also cuprates only. But you put a withdrawing group to them, they become more nucleophilic. So that is why they do, the yield of the products is better. They do the similar reaction. At your level, we don't consider them different. There is no reaction I've given you where cuprates, like Gilman can work and cyano cannot work. So I didn't give you any because it's not at your level. It is the people who are taking chem majors and they are working with integrated biochemical processes in the labs. I have to teach them because they are connecting the two dots together. Because organochemistry, organometallic chemistry and organic chemistry is actually biochemical sciences. So when these students go to the majors, chem majors, they choose that, okay, I want to, do this. So I have to give them a clarity in the advanced courses that you can't do cuprates here or you can't do cyanocuprates here. But at your level, I just told you in the class, altogether.
Isn't the lower level ones master can't do with oxide or it can do with oxide?
Say again?
The lower level organic can do with oxide?
I'm going to go there.
Oh.
Now, I wanted also to, which I just want everybody, limitation of cuprates. Cuprates do not like these substrates. This is at your level. Cuprates love the first and second. That's why I didn't give that limitation. That means I will never messing up your life ever with this. I will never give you this combination ever. I will never give you this combination ever, 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 because I am wrong if I'm giving you, because they do work. So what combination you can only give us? I will only give you any combination which I gave you on the rest. I've given all these questions in recitation. I gave you this combination. And this does not work. So this, I'm not going to give you, erase them. That she's never going to give us cuprates with an aldehyde. So not in the course. So not in the learning course. Only thing is, I want students to understand that cuprates do not behave with ketones. They are very slow and difficult reactions. They go differently, completely differently. So it's not in the learning goals to do aldehydes with cuprates. Because it's wrong for me to say that they don't work. They do work. Fantastic. So it's bad of me to. But why did I delete? Why did the team decide to delete that? It's confusing. Aldehydes work, ketones do not work. But those who are interested coming in the lectures, they must be realizing that the other day I said that aldehydes are more reactive than ketones. That's how they work, right? But we are not, I do not want, because there are many students sitting in my class who just want to get rid of organic chemistry because they don't like it. It's okay. You can't like everything, right? But it's a path. But if you want to go to the biochemical path, you better start liking it because it's going to be used everywhere. So, but I respect every one of them that, okay, not necessarily if you like it, everybody should like it. No, not necessarily. So that's the limitation which is written on the notes. That, and I gave this question because I wanted to be very sure about that story. So the first discussion question talks about this, where I gave you and I said, oh, can you use a cuprid? And I gave that same reagent on the cuprid. And the answer was no. You can't use cuprid. So if you do question 1 of recitation, it's all about this. Good? Okay. Everybody good with 15? Any question for 15 now? Yes.
For the Mg halogen, is the halogen only bromine and iodine?
Yes. In your case, the halogen is MgCl, MgBr, Mgi. You cannot prepare ever organometallics with fluorine the same way. They do something else. So they change the course of reaction. So I just can't take an alkyl fluoride and I say, oh, I'm adding magnesium to that. Are you kidding me? I'm a very ionic compound. I'm not going to work the way everything is working. So we never prepare organometallics. Any other question? Yes, dear.
Could you go over the try question on page 6?
6? 6. I'll go like this so that I can directly read 6. This is 3, 4, 5, 6. Okay. Which try problem? This one?
Yeah,
These ones, right?
Yeah.
So what I told you is, the question was circle the compounds which cannot form Grignard agent. So, Grignard agent is RMGX. See, my question was not that. This is the thing. Now, question was not that which of the following cannot form organometallic. My question was which of the following cannot form Grignard agent, right? Now, I wanted the R to be Mg. Now, what happens is, I took this compound, I added magnesium to that, and I thought that it's going to form MgBr. But what was the product? This was not the product. What was the product and the reaction mixture? The product in the reaction mixture was this. Intramolecular reaction occurred. Deprotonation occurred. I'm negative. Oh. So this was the product. So I said, damn, acidic hydrogen is really messing up the story. This is not the only one. There were many other products in the reaction mixture. Because this was so basic. Right? So I said, I give you the reasoning, whenever you see acidic proton, it's not a good idea to make Grignard agent. 2. I just now answered that question that fluorides never form Grignard agents. So second answer is fluorides cannot make it. So I just cross this. This also cannot. Now in this case, do you know Grignard agent is dissolved in ether? Right? That means they are not reactive to ethers at all. I can easily use. What is O? Ether, right? So Grignard is said, yeah, make it. Then I saw acidic hydrogen. I said no. Then I said anything with a multiple bond, nucleophile will come here. If you make MgBr, everyone knows that, right? So wherever, that's the thing I've written on the top. Multiple bonds, acidic hydrogen, multiple bonds, acidic hydrogen, they never form Grignard. I cannot form Grignard agent from oxirane also, because it reacts. Oxirane is, now a lot of students saying that, oh, oxirane is an ether. No, oxirane is a strained ether. You see that? It's a straight bond. It pops up. It said, oh, give me the nucleophile I want to open up. So that's why oxygen there. You can't use, if I put a Br here, you can't put a greener agent here. Clear? Everybody good? Is chapter clear? Okay. 13 and 14. I think the 13 and 14 just talks about numbers and